Welcome back to Uncle Fish. This is the final part of the series for Programming Foundations. Today, we are going to talk about the different types of languages that are out there and how some of these languages function. Just to recap where we left off. So, part one, we talked about binary, how to take zeros and ones, basically at the machine level, all the way up to like characters, basically. And then from part two, we talked about the role of the CPU, the role of CPU architectures, and how do we write like instructions basically from higher level languages down to assembly and then eventually down to the machine code languages. And so today we're going to spend some time on the higher level languages. Okay, so the higher level languages, there are, I don't want to say hundreds, but it certainly feels like there's hundreds of them, right? And there are all sorts of different functions and reasons as to what those languages are for. And so starting in computer science, it becomes really daunting to know like, well, what should I be focusing on? What should I learn, right? Um, so let's first talk about what's happening or the different types of languages and then ones that we're going to focus upon, okay? So let's categorize them into, for example, compiled versus interpreted. This is one kind of broad category of languages. We'll talk about that in detail. There are definitely, like I said, other categories. There's declarative versus imperative. There are there are languages, scripting versus programming, languages that are considered markup versus programming as well. And I'll give you some examples of some of these, right? So, for example, from a markup language perspective versus a programming language perspective, it's basically describing your like HTML. Boy, there you go, HTML, XML, for example, CSS, things like this, right? That are considered markup languages versus programming languages, which are your, Pythons, for example, Java, so on and so forth. There are languages that are scripting versus as well, right? Scripting languages like Bash, for example, shells versus programming languages. And there's some that are kind of in between that do both, like Python, for example, right? I apologize for the really messy handwriting here in this particular video. The ones that we're really interested in that we're going to talk about is here. It's on the compiled versus interpreted. As I believe this is really going to help you as you learn C++, Java, whatever you're learning, right, in your next stage. And I think once you've learned that foundational type language, then the other languages to me become much easier to understand. So what do we mean when we say something is compiled versus something is interpreted? Well, let's first talk about when we're looking at what compiled mean. We kind of went over this in phase two, but we'll recap here as well in part two. So at the bottom was this machine code. So we were getting eventually down to the ones and the zeros, right? And we had assembly that was sitting on top, right? Assembly language. And then we had your higher level language here, like C++, for example, and Java, so on and so forth, right? And we had the translators that were going in between these layers to eventually get you that. So this was come from all from review from part two. So C++, for example, goes through when you are wanting to run that code is you are going to write some source code and you are then going to compile that source code. And when you compile that source code, you'll see things in your class like GCC, GCC++, so on and so forth. But when you're compiling that source code, you are essentially writing it to machine code. And remember what we mean by that. Machine code here is the machine code for your particular CPU architecture, right? The RISC versus the CISC architectures. So one of the drawbacks with these kinds of languages, for example, and C++ is one of them, is that you are writing it and compiling it multiple times for the different architectures that you have because the machine or the instruction set for those architectures are different and you're going straight to that machine code. So a good example of this is like Microsoft Office. You can't use the same Microsoft Office that you're running on your Windows machine that's running on the CISC that you can also then go off and run on a RISC-based system, right? Like the new Macs, for example. And again, like I said in the other video, like we are grossly oversimplifying this, right? There's lots of other things at play here, operating systems, so on and so forth. But the main drawback here was that companies, developers, what have you, would have to go off and now compile for all the different types of machines that they supported. And um, this has overhead. Now, the benefit of this, of course, is that you're compiling right down to the machine code. So at runtime, you're at the lowest level. This is going to be super fast, right? As an example. Um, if you look at the opposite of this, which was the, for example, interpreted languages, so outside of C, C++, and Go, right? So I should give you these examples. So C, C++, and Go. These are examples of things that are compiled languages. There's a contrast. The contrast is going to be the non-compiled languages, right? The interpreted languages. So we'll talk about that here in a second. But before we go there, let's spend a little bit of time to see like what exactly is happening here. How does this guy work? How do you compile source code right into something that then a machine can learn? Well, you have compilers, and people have gone out and written those compilers for you. Like I mentioned, when GCC, there's a bunch of other ones, G++, C++, GC++. So lots of different compilers that are out there. But what are they doing, right? The compiler is going through like stages. So imagine that you are trying to assess a language, right? Somebody is speaking to you in a language and you want to go assess that particular language so you can make sense of that language. So there's the lexical analysis, which is a fancy term for the language analysis, right? There's a syntactical analysis, like are you following the rules of the grammar, right? In any language. Same thing goes for programming. There's semantics analysis that are the semantics of that particular language. So it's not just syntax, but the semantics of loops and other types of constructs that are provided for you in that language. And then finally, the code generation, right? Taking all of those things and converting it, doing the actual conversion down to machine. And each one of these has its own level of complexity, right? With parsers and all sorts of other things, complex data structures. Writing a compiler is not an easy thing by any means, right? But we have them for us as higher level language programmers. And so we need to make sure, like, not to take that for granted. So when we're talking about compilation, this is what's happening here. You will get errors that are syntactical, right? Logical errors, semantic errors, things like this that are catchable at the compilation stage. There are other types of exceptions and errors like runtime errors that you will only see when you're running the program. Okay, so when you compile, it's going through these four stages and more, but these generally these four areas and coming up with machine code. Okay, hope that makes sense. Now to draw the comparison to interpreted languages. Remember, one of the drawbacks of these types of languages, you had to compile them for each of the different architectures. Okay, so when you look at the opposite of this, which is the interpreted languages, it's similar to what's going on here. The only difference is that imagine that I had CPU type 1 here that I was writing to and CPU type 2 that I was writing for. Remember before we had to do compilation in those programs in C++ for each one of these. In the interpreter or interpreted languages, there is already some interpreter that's sitting here on these computers, on these machines. And so long as you have that interpreter for you, then you can go and deploy your code that you don't have to compile. So like Java code, for example, and we'll talk about some of the details within this, Python, for an example. There's a bunch of other, these Perl, so on and so forth. Those are all considered interpreted languages. What's happening there is that you're actually, some of them, we'll describe Java in a little bit and even Python. There are some higher level stages of compilation that's happening, but again, we'll touch upon that in a second. But basically what you're doing is you are writing something for an interpreter to understand, and that interpreter then does in an optimized way, converts what it needs to in time over to that particular CPU. So you don't have to compile, right? You can make your changes one time. You don't have to compile them for the different versions of the CPU. You can take the exact same code that you wrote here and you can send it over to the interpreter as long as that interpreter exists on that particular CPU architecture. So hopefully that part makes sense as well. And there's a massive benefit here, right? Especially in Java, which was originally intended for like mobile and web, right? Was this whole notion of being able to write your code once and run it anywhere, right? As long as there was an interpreter or something there for you to execute the program and eventually compile it down, or I'm sorry, run it down to the machine code. So these are the differences. Now, again, there is some drawbacks of this. Now you have this middle layer in the interpreter, and there's people that believe that having that other middle layer makes it slower, these programming languages, in comparison to having something going directly to the machine code, which again, that to me makes sense. Now, what's better, Java, C, Python? That's completely out of the scope, right, of this particular video. What we're here to do is to try to convey and instill some of the, again, foundational principles of programming so that you can understand what exactly you're doing when you type those commands like GCC and such, and why you're having to go do that. Okay, so hope that makes sense. I will spend a little bit of time on Java just because Java is one of the really popular languages out there. From the language hierarchy perspective, I would say Java is probably somewhere in the middle there from an interpreted language perspective, meaning that it has some of the qualities that compiled languages have, and then, of course, the qualities of the interpreter. And the only reason why I'm making that distinction is because Java will write to this level of like an interpreter. It will write it in bytecode. That bytecode then is run inside of a JVM, a Java Virtual Machine. And there's been lots of money and time and effort spent on trying to optimize that particular JVM so that it does things in a faster way, right? So I think it sets itself apart a little bit from the other more scripting type languages, but nevertheless, right? So you have, as long as you have that JVM in that right place, you will be able to go write your Java code. You can compile it into that bytecode, and then you can go run that bytecode anywhere. And then again, that code will then get translated using just-in-time compilation when needed in an optimal fashion down to the CPU or to the machine code. When we think about, for example, other languages, right? So think about JavaScript, for example, which very confusing to people. They always think that Java and JavaScript are the same thing, and they're not. But JavaScript, for example, has a similar type problem, right? It's a language that's run inside of a browser, but who's running that for you, right? Who's the one that's doing the compilation of that particular language or the interpretation of that particular language, because it is interpreted. So who's doing that? Well, each browser actually does that for you, right? Firefox has an engine. Chrome's engine is, I think, called V8. SpiderMonkey, I think, is the one that's used for Firefox. IE has one. Safari has one. All of these different engines, and again, they do things a little bit differently, right? But that's your interpreter, basically, that's going to go execute your JavaScript code for you. That's the interpreter, for example, that's going to go execute your HTML code for you. So all of these different languages eventually, like I said, have to get down to machine code at some point. Right? So hopefully that makes sense, and hopefully that helps. We're going to carry this discussion on now and focus to actually writing code. So the next set of videos are going to be learning C++ programming. I can't emphasize enough how important learning these programming foundations is, and not jumping straight into the source code and writing, our first hello world, which we'll do next in C++, but to understand some of these fundamentals, because they really will help you into the future. Thanks for listening, and stay tuned.